Assalamu alaikum, my dear student. Wishing all of you a very happy new year. Let's start this year with new hope and joy and full of energy. Okay? Today I will discuss chapter 3, which is force, and I will discuss two creative questions from this chapter. Please give your concentration and learn these two questions. So, my dear student, this is our first creative question, and here you can see that the STEM is a car of mass 5000 kg starting from rest and moves, and after 50 seconds its velocity becomes 10 meter per second. After traveling 1 kilometer with this acceleration, it collides another car of mass 60,000 kg at rest. After collision, both cars in a body is moving with a velocity 9 meter per second. Okay, so this is our first creative question, STEM. Okay, and this is number A question. So number A question is, write down the second law of falling body. So my dear student, do you know what is the second law of falling body? The velocity v acquired by a freely falling body from rest in given time t is directly proportional to that time. Okay, so if I denotate the velocity by v and if I denotate time by t, then the velocity will be proportional with the time. Okay, I hope you understand what is the second law of falling body. And here you can see that this is our number B question, and here you can see that the question is, the traveling distance of a moving body is not zero, but its displacement can be zero. Okay, so if I want to explain this question, at first we have to know what is the meaning of distance and what is the meaning of displacement. So do you know what is the meaning of distance? Distance means the difference between the initial position and the final position. But what is the meaning of displacement? Displacement means the shortest difference between the initial position and the final position. Okay, so if a body can go forward and then come back to its initial position, or the body can move in a circular path, okay, and can come to the point where it has been started. So in this case, the traveling distance of the body is not zero, because the distance between because the difference between the initial position and the final position cannot zero, but its displacement is zero, because the smallest difference between the initial position and the final position can be zero. That's why the traveling distance of the moving body is not zero, but its displacement can be zero. I hope you understand. So, my dear student, here you can see that number C question is, determine the acceleration of the car. That means I have to find out the acceleration of this car for this 50 seconds. Okay, so here you can see that at first I have to write all of this given values. Okay, so here you can see that the initial velocity for this car is 0, because that was in rest. Okay, so the initial velocity u equals to 0 meter per second. And what is the time? The time is 50 seconds. So t equals to 50 seconds. What is the final velocity? Here you can see that the final velocity after 50 seconds is 10 meter per second. Okay, so v equals to 10 meter per second. And finally, I have to find out the acceleration A equals to what? Okay, so my dear student, if I want to find out the acceleration A, then we know that what is the formula of acceleration. Okay, so we know that the acceleration A equals to V minus U by T. So here you can see that the V, that means final value equals to 10, the initial velocity equals to 0 and the time equals to 50. Okay, so acceleration A equals to, if I calculate this, then I will get 0.2 meter per second square. Okay, and that is the acceleration of first car for 50 seconds. Okay, so I hope you understand how can we find out the acceleration of this car for 50 seconds. Okay, so my dear student, this is our number D question. Okay, and here you can see that the question is the changes of momentum of these two cars are not equal and opposite due to collision. Why? We have to explain it mathematically. Okay, so we have to find out the changes of momentum for first car, and after that we have to find out the changes of momentum for second car. Okay, and then we will analyze all of this changes of momentum. Okay, so if I want to find out the changes of momentum for first car, here del P1 equals to M1 V1 minus M1 E1. Okay, so the mass of first car is 5000 kg. Okay, 5000 into the final velocity for the first car. Here you can see that after collision, both cars in a body is moving with the velocity of 9 meters per second. So the final velocity for the first car is 9, and again the masses of first car is 5000, but we don't know the initial velocity for the first car, because after traveling 1 kilometer, which velocity will gain by the first car, that will be the initial velocity for the first car for this collision. Okay, so I have to find out the velocity of the first car after traveling 1 kilometer. So here you can see that we know the distance. 1 kilometer means 1000 meters, and we know the acceleration is 0.2, which we have got from question number C. Okay, and the initial velocity of the first car for 1 kilometer traveling distance is 0, because the car is in rest. Okay, so by using all of this given value, we know that the final velocity v square equals to u square plus twice as, where v square equals to u0 square plus 2 into 0.2 into 1000. Okay, 1 kilometer means 1000, so v square equals to 400, and if I root this, then the v will be 20 meter per second. Okay, this final velocity after traveling 1 kilometer for the first car, that will be the initial velocity for the collision for first car. Okay, so the initial velocity of this car is 5000 into 20. Okay, so if I calculate this value, then I will get minus 55,000 kg meter per second. Okay, and this 55,000 kg meter per second is the changes of momentum for the first car. Okay, and here if I want to change the momentum of second car, then del P2 equals to M2 V2 minus M2 U2. Okay, and the mass of second car is 6000 into the final velocity is 9, and the masses of second car is 6000 into the initial velocity for the second car is 0. So I will get 54,000 kg meter per second. So here you can see that the changes of momentum for the first car and the changes of momentum on second car are not equal, okay, and they are opposite from each other. So my dear student, why that is happening? It is occurred according to the law of conservation of momentum. So according to the law of conservation of momentum, if the changes of momentum of one body is increased, then the changes of momentum of the other body will be increased and they will be opposite from each other. And dear student, I hope you can understand why the changes of momentum are not equal and opposite from each other. So my dear student, this is our second creative question, and here you can see that the question is mass of an object is 5 kg and its position is steady. That means these objects are at rest. Now 5 Newton force acts on this object for 4 seconds. After 4 seconds, again 10 Newton force act on this object for 4 seconds. Okay? So, and this is number A question. Number A question is what is called wave. Do you know what is wave? Okay, let me explain it. Wave is a process of transferring energy from one place to another place through a medium where the particles of medium can oscillate about their position but not displaced permanently from there, and that is called wave. Okay, and number B question is write down the characteristic of the image which is created in a planar mirror. Okay, the answer is the characteristic of the image formed on a simple mirror or plane mirror are as follows. That means all of this are the characteristic of the image which is created in a plane mirror. Number 1, the equal distance from the mirror. That means at where the image will create, the distance between the mirror and the image will be equal to the distance between mirror and object. Number 2, the image will be virtual. Okay, and the same length. That means the length of the object will be equal to the length of image. And number 4 is erect. Okay, so I hope you understand what is the characteristic of image which is created in a plane mirror. So my dear student, this is number C question, and here you can see that the question is determine the distance for the first 8 seconds of the object. That means I have to find out how much the object will cover in 8 seconds, but I cannot find out this distance directly. At first I have to find out the distance covered in first 4 seconds and then the distance covered in second 4 seconds. Then if I add these two distance, then I will get the total distance which will be covered by the car for first 8 seconds. Okay, so let's start to solve this math. If I find out the distance covered in first 4 seconds for the object, then here you can see that I know force and mass, and by using force and mass I can find out the acceleration, and I know that the acceleration A equals to F by M, where F equals to 5 and M equals to also 5. So the acceleration A equals to 1 meter per second square. Okay, so by using acceleration, time and the initial velocity, I can find out the distance covered in first 4 seconds. So what is the distance covered in 4 seconds? I know that the distance S equals to ut plus half a t square. Okay, where u equals to 0 because the object is in steady position. Okay, and the time equals to 4 plus half into 1 into 4 square. So if I calculate this, then I will get so the distance covered in first 4 seconds S1 equals to 8 meter. Okay, so now I have to find out the distance covered in second 4 seconds. Okay, here you can see that, my dear student, after 4 seconds again 10 Newton force is applied. That means after 4 seconds, which velocity will gain by this object, with that uniform velocity this object will move for next 4 seconds. Okay, so if I want to distance covered in second 4 seconds, at first I have to find out the velocity after first 4 seconds. Okay, so the velocity after first 4 seconds, v equals to u plus at, where u equals to 0 plus a equals to, here you can see that I have already got this acceleration, a equals to 1 into time equals to 4. So I will get 4 meter per second. So the velocity after first 4 seconds will be 4 meter per second. So with this uniform velocity, this object will move for next 4 seconds, because after first 4 seconds no force is applied. I hope you understand why this car will move with that uniform velocity. And here, if I want to find out the distance covered in second 4 seconds, and for this uniform velocity, we know that the distance is equals to Vt, where v equals to 4 and t equals to 4. That means S2 equals to 16 meter. And here you can see that, my dear student, for first 4 seconds this object covered 8 meter, and for second 4 seconds this object will cover 16 meter. So the total distance S equals to S1 plus S2 equals to 8 plus 16 equals to, so the total distance will be 24 meter. And I hope, my dear student, you understand how can we find out the total distance for the first 8 seconds of the object, and the total distance equals to 24 meter. So my dear student, this is number question D. And here you can see that analyze the motion of the object by drawing the velocity versus time graph according to the information of the stem. Okay, that means I have to draw the velocity versus time graph. So here you can see that if I want to draw this velocity versus time graph, then I need to draw this by 3 steps. Okay, for the first step, so my dear student, for the first 4 seconds the initial velocity E1 equals to 0 meter per second, but after 4 seconds the final velocity will be 4 meter per second, which we have already got from question number C. So at the initial state, that means the 0 time, if I put a circle, and at the time 4 seconds, and the velocity will be 4. So the graph will look like that. Okay, and I have to put a circle on that position, and after that I have to connect these two lines. Okay, and for the second force second, the velocity v2 will be 4 meter per second still, because after first 4 seconds no force will be applied on that object. That's why the object will move with the uniform velocity and the velocity will be 4. So for the next 4 seconds, that means 4 to 8 seconds, the velocity will be still 4 meter per second. And if I put a circle on that position and denoted by B, and after that if I connect this two line, then it will look like that. And okay, and for the third 4 second, what will be the velocity? Okay, here you can see that for the third 4 second, that means 8 to 12 second, the initial velocity is 4. Okay, so after 4 seconds, if I want to find out the final velocity, then what will be the final velocity? V equals to U plus AT. V3 equals to U3 plus AT. But here you can see that we don't know the acceleration for the last 4 seconds. Okay, but here you can see that we know that the forces which is applied on that object, so we can easily find out the acceleration. So acceleration A equals to F by M. So 10 by 5 equals to 2 meter per second square. Here M mass equals to 5 kg. Okay, so if I put this acceleration in that equation, then I will get U3. Here U3 means the initial velocity for the next 4 seconds. Okay, so the initial velocity equals to 4 plus acceleration equals to 2 and the time equals to 4. So I will get V3 equals to 12 meter per second. Okay, so the initial velocity for the next 4 seconds is 4 meter per second and the final velocity is 12 meter per second. Okay, so if I want to put a circle, then 12 and 12. So I have to put a circle on that position, and this is denoted by C. Then if I connect this two lines, then it will look like that. So this is the graph. So this is the graph of velocity versus time. And my dear student, I hope you understand how can I draw this graph of velocity versus time. Okay, so my dear student, I hope you have enjoyed the class and you have learned all of these two creative questions which I have already discussed with you. And please write down these two creative questions in your copy and send it to your subject teacher. Assalamu alaikum, my dear student.